So welcome to this webinar. My name is Laura Denale. I am from Euronovia. We are the partner in charge of communication and dissemination for the SCORE Horizon 2020 project. This webinar is jointly organized by SCORE together with 3 other European projects, Protect, CoCliCo and West Coast. So you have here some information in this slide on the projects. As you can see, all of them are Horizon 2020 project with a similar duration. Protect will end this year, and the CoCliCo and SCORE next year in 2025, and finally West Coast in 2026. So we are still running for some time. So since our 4 projects have a common scope, which is to enhance climate resilience in coastal areas, last year we decided to team up and with the support of the European Commission, through a service called Horizon Results Booster, we formed a project group called Adapt4Coast. And so the objective is to join forces and reach a greater impact for our projects. This webinar is one of the joint activities we are doing to disseminate our project results. And as you can see in the agenda, we have representatives of the 4 projects here who will present some of the tools and platforms that are under development to help communities plan smart adaptation strategies and play an active role in tackling climate-related challenges. And in the last session, we also presented the Adapt4Coast joint policy brief that we have drafted together. So let me give you just a few practical information before we start. The webinar is being recorded and it will be made available online in the next days. And also, due to the tight schedule, we are not taking questions after each presentation, but you can ask your question in the Q&A tab or in the chat here at any time, and we will answer them during the Q&A session at the end of the webinar. So without delay, I now give the floor to our first speakers from the SCORE project, Mar and Tasnim. Thank you.
Thanks, Laura, and good morning to everyone. My name is Marieta, and I'm working as a researcher and consultant at ENT Environment and Management. So to start with the session today, I wanted to present you the SCORE EBA catalog that we developed within SCORE project. With this, we intended to present a set of ecosystem-based adaptation, or also well-known as nature-based solutions, suitable to address hazards related to coastal and climate change adaptation and mitigation. So here, let me very briefly present the tool. How can you explore the catalog? So first, you could find, or you could go through a case study map tour. So on the left-hand side of your screen, you might see all the different EBA entries that we came up with. As you can see on the right-hand side, it pinpoints where the case study is located. But if you click on it, you might find a representative picture together with a definition of the measure, the main objectives, and the main additional benefits that this measure could bring. So you either close it and you select another option, or if you prefer, you might scroll down the screen to go through the entire options. Then on the horizontal menu, then you might select to filter these EBA solutions by a land type, for instance, or by a hazard. Let me very quickly show you. So if we select categories, you will see that we came up with 6 different land categories running from urban green, permeable surfaces, river floodplains, wetlands, coastal shoreline, or marine waters. We developed different icons to be more visually friendly. So if you go to the I option, then you will see that it stands for coastal erosion or marine waters, wetlands, so on and so forth. What can we do here if we want to explore the interactive map? So you will see on the right-hand side the menu. So you could either select by clicking here, hope you can see it, so the different line type, and then you will see here listed what are the EBAs that are suitable to be implemented in this line typology. So for instance, imagine then within urban green, I'm interested in knowing more about deforestation. So I just click it, and here it pops up a very brief description of the case study that we selected, a representative picture, but we are also being referred to the original source of the measure. Whereas we can do, we could, for instance, choose another option, in this case, green corridors. So you can see that I can very quickly see where this case study is located. And again, I can see the description. Second option for filtering is if you are interested in selected by the hazards. So again, we have icons representing the most relevant hazards related, as they could be sea level rise, coastal flooding, land or river flooding, coastal erosion, storm surges, droughts, and landslides. Now, again, if we scroll down, we can come up with our interactive map. And again, we will see here how or which are the different categories. If you can see, most of them are suitable for coastal flooding. But for instance, if we go through sea level rise and we are interested in exploring oyster reef restoration, will be directed to the location where the case study that we selected is relevant. Again, the description, in this case, it is based in the USA. And again, we could be referred to the original source of the link. But maybe what it could be most interesting to you is that we could filter either by selecting a hazard and at the same time selecting a category. So here again, if we go under category, we might select one of the land typologies. For instance, it could be wetlands. Then I also want another measure that is suitable within a wetland to address coastal flooding. And I should activate both of them. And then I should be able to see on the map where the measure is. So now if you zoom into the map, we will manage again to identify which is this EBA option that could be of interest to us. So here I have it, then you click it, and again, you see the similar sort of description, the link to the original source, and again, the picture. So very briefly, this is our tool that we came up with within a SCORE project. Still, we are trying to improve it within the life of our project before it finishes. And now I want to give the floor to my colleague Tasneem, that she will introduce you low-cost sensors catalog.
Hello, everyone. Good morning. I hope my screen is visible.
Yes.
So good morning. So my name is Tasneem Ahmed, and I'm a third-year PhD student at ATU Sligo. And today I'm going to present the SCORE sensors catalog. So catalog is essentially, it consists of different low-cost sensors that were identified from the scientific and gray literature to monitor different environmental parameters corresponding to different hazards mapped in the 10 coastal city living labs within the SCORE project. So of course, the link to this catalog will be provided to you guys. And you can see that there are various low-cost sensors which have been identified. And the purpose of these low-cost sensors is not only to complement the data coming in from institutional sensors, but also to engage citizens in these monitoring activities. So I'm just going to briefly go through some of the sensors and how you can access this catalog. There are many interesting sensors that might be useful for your research purpose or for any other activities. So as you can see, there are different filtering options here. The first option here is the hazard. Now you can select multiple hazards depending on your interest. For example, I select here storm surge. You can also select sea level rise, just as an example. And normally for these hazards, the parameter that you want to monitor is generally, let's say, the water levels. Okay, so you can see that some sensors have been filtered already. And then there is another option for installation complexity. So there are different installation complexity for the different kind of sensors here. And as an example, let us choose the one with neutral. Okay, so here we have 3 sensors filtered out. So you can also choose the price range here depending on your budget. So okay, let's say that we want to keep the price range from 0 to 2,000 euros, because here we are basically talking about low cost sensors. So you will find that the sensors are not that expensive. And you can select in any sensor that you are interested in. For example, let me select this one. So this one is a water level logger from this company called Onset. And this is a sensor which is currently implemented and is going to be installed in different coastal city living labs. And it is currently being installed in Sligo in the northwest of Ireland. So here you will be able to find a brief description of this sensor. Okay, so the parameters that you can monitor with the sensor, that is the water level, the corresponding hazards, and the price of the sensor. Okay, and the minimum number of quantities that you need. So the minimum number of quantities would be 3. So you can select the minimum number of quantities that you want, and you can simply add it to the cart. Just like a typical shopping website. And you also find different properties for this sensor. For example, if you click here, you will find the sensor properties, which will tell you what is the accuracy of this sensor, then in what unit does it measure the water level, and all the other things regarding connectivity like Wi-Fi, if you need any external power supply. And if you need more documentation, you can click on this link. There are more information available here. Then there is something known as historical information. That is, I mentioned that most of these sensors have been mapped out from the scientific literature as well as gray literature. So in historical information, we try to provide here the links to previous research in which such sensors were utilized. Then you have the operation complexities. So, like regarding the purchase, the assembly of the sensor, deployment, like how easy it is or how difficult it is. And we have a section for citizen science. That is, how we engaged citizens for this particular sensor, and also some like ideas regarding, how we can involve our interested stakeholders in it. So as you can see here in citizen science activities, we have provided description of, how to involve the public in the assembly process, then in the deployment process, and of course, the data that will be retrieved, how we will analyze the data and how can we engage the public in it, okay, as well as the target users. In our case, the target users are, of course, the local groups and the local authorities. And if you have a data analysis software in place, then you can also, then we have also provided some ideas on it, like how can we, analyze the data. And then we also have a list of the possible suppliers for this particular sensor. So basically, this is just example of one of the sensors, but there are so many sensors here, and all the possible information that a user would want is provided here. So you can go through each of these in details and in your own time. So after we have added this to the cart, you can select as many quantities as you want, and then you simply check out. And then you put your details here, and then you simply place order. So what happens is that when you place order, all the sensors that you have selected, so in order to access this catalog, you need to log in. So you will get all this information regarding the price and all the reference quote in your mail. So so just like I explained, of course, there are a lot of sensors, and you can play with many of the sensors. Some of the sensors, like for example, smart pebbles, could be quite interesting for you, because like this is something that was carried out recently in Sligo and Dublin. And similarly, you find, all the required information as well as frequently asked questions. So these have been tried and tested, and it could be quite, interesting for you guys. So so this is what I had to explain about the sensor catalog, and now I will pass it on to the next speaker. Thank you.
Yes, so the next speaker is from CoCliCo, Gonri Le Cosanet.
Thank you. Thank you for this presentation, and so thank you for the opportunity to present the CoCliCo project. So I'm going to make a slightly different presentation, because our tool is at earlier. It is an earlier stage of development than those of SCORE. And so this CoCliCo project is supported by the European Commission, and you can see here all the partners. So thank you to them for their efforts to make this project. Sorry. Okay, so I'm going to provide a bit of context. So as you know, sea level is rising, and it has been rising by about 20 centimeters since the early 20th century. And we know it will continue to rise. So compared to other impacts of climate change, we know that sea level rise is going to continue to rise for centuries. And we can stabilize the rates of sea level changes, but not sea level themselves. It means we are going to need to continuously implement adaptation over time. And this is a very specific aspect of climate change, this aspect of being in a position to have a change that continues over centuries. So if you look at the hazards, because we are not adapting to sea level rise itself, but to the hazards, you can see that with the 20 centimeters of sea level change that we had globally since the 20th century, we are starting to see some high tide chronic flooding events, like the one you can see here. So we can see them, for example, in the subsiding area in the US. And we are also experiencing higher extreme water levels during storms, which can materialize with very strong events like this one here in 2010. For erosion, permanent flooding, and salinization, these are processes which exist today, but we expect sea level rise to have a major impact later in this century. So we're progressively going from a situation where natural variability and the impacts of human activities dominate to another situations where sea level rise is the main driver of increased coastal hazards. So to support the practitioners of coastal practitioners, we need climate services to help them taking decision to adapt to these future coastal risks, which are going to increase. So the literature on climate services has been very much framed by this paper by Helen Hewitt in 2012, which displays a bit what could be the components of the different climate services. So on the one side, you have users. On another side, you have platforms. And here in this project CoCliCo, we need to develop a platform. But the platform itself can only exist because there is observation and monitoring, research and predictions, and capacity development like education and training. We know that these climate services are developing, but we are still lacking decision-oriented climate services and platforms that really support policies. And this type of tool is still in early development. We know the barrier to these climate services. This is the lack of perceived usefulness of existing services, the lack of expertise to use the information on the user side, the mismatches between the needs and the type of information made available, the insufficient engagement with users from the climate services developers. And we also have to know that business models are unclear for the sustainability of the services. This is referred in the publication below, including this one, which is from the IPCC report. So if you look at sea level rise, for example, one typical platform that you can, let's say, you can identify it as a climate service is the climate central tool, displaying where, let's say, the topography is lower than the high tide area, plus some, let's say, additional water levels due to sea level rise or a storm. And you can see that if you visualize this area, already today we have a lot of area, especially in the North Sea, that are below high tide sea levels. However, they are not flooded because they are protected. And in practice, even if they were protected, they wouldn't be flooded entirely because flood only occurs during a very small period of time during which the tide is high. So here, for example, you have flood maps done by our colleagues of IH Cantabria, which displays where what would be flooded if you had one centennial event occurring in the North Sea and no defenses. In practice, there are defenses. So our project aims at improving decision-making on coastal risk management and adaptation by establishing a platform to support coastal adaptation to sea level rise. And this project is built around 3 pillars. So the first one is about interacting with stakeholders about specific decision problems, like the Food Directive implementation, the cities and towns adaptation in relation to SCORE, the coastal infrastructure like ports and electricity production. On the other side, we have the production of scientific data on the different components of the coastal risks, meaning the vulnerability and exposure of people, infrastructure, and to some extent ecosystem, the coastal hazards like flood and erosion, and of course the drivers of change of these coastal hazards, which are the sea level rise and some changes of surge and waves due to climate change. We also consider adaptation, which can be acting on the hazard. This is protection. On vulnerability, this is accommodation, or on exposure, and this is relocation or setback zones. In between, we need to develop an open web platform. And so the key point here is to have something that is fair, so findable, accessible, interoperable, and reusable according to the existing standards. So where you can find the data, but also you can find the sources of the data and all the limitation and the potential, which allows you to reuse. So the target resolution of this project is 25 meters to 100 meters, depending on the data sets, allowing for zooms in some specific areas. We know it's not completely satisfactory for flooding because flood modeling would require 10-meter resolution ideally, but the data sets are not available yet. And the main focus is Europe, so the 28 members of the European Union plus UK, extended to the Europe region as defined by the IPCC. So today we have a platform which is still restricted to to the project partners, which look like this, where we have actually included some data developed by previous project, like for example the project led by Michalis Fousdoukas at the Joint Center of the European Commission. So these data are available. It allows us to demonstrate that we're able to develop such a platform which meets the FAIR requirements, so findable, accessible, interoperable, and reusable. But when we have developed the platform, we expect to help decision makers to visualize what could be the impact of a different adaptation option. And this is a major innovation, the major expected innovation of this project. If you look, for example, at this estuary, this is a Seine River estuary in France. Basically, you have two options on the long term. Either you protect the estuary from being flooded, or you use a combination of nature-based solution with relocation. And depending on these options, the flood maps will be different. And this is potentially the major innovation compared to previous platforms that we expect to develop this platform. We need to implement integrated scenario. We need to select parameter space and scenario space, so parameters and scenario that are consistent across all components of the risk, so hazard, vulnerability, exposures, and these are explained here. We consider the following time horizons, so 2150, this is really the typical time horizon, but also mid-century and mid of the next century. Return period events that are here. So the centennial event is, of course, very important. Climate change and linked socio-economic scenario, which are here. And two adaptation options, business as usual adaptation, we raise defenses as sea level are rising, and cost-efficient adaptation, where we allow a relocation where it is not cost efficient. We do not say this will be the adaptation in the future, but these are typical scenarios that can be used to explore the potential options. But in the end, we need to think about how this service will be used, because in practice, what adaptation will these climate services will inform? It's important to think about the fact that the IPCC has made clear that with incremental adaptation, focusing on only defending the coast, for example, or implementing relocation without thinking to the other components of adaptation, like water management, fisheries management, etc., we may miss the best opportunities that we have, which is to create an opportunity to create more resilient coastal environment and coastal ecosystem. So here you see a figure from the IPCC report, which displays two futures. One with where basically adaptation and mitigation fail, and there will be adaptation in this case, but living condition will be much less, much worse than today. And here, an option where we succeed to stabilize climate change and to implement adaptation. And there we have succeeded to create a better condition for human and for the ecosystem. And I think that with the climate services we are developing, we must be very careful that they are used in a way that does not prevent people from realizing that adaptation is not only a technical matter, but it's also a political choice. And basically, we have the choice between these two features. So thank you for your attention. And if there is time later, I will be happy to respond to questions.
Thank you very much. Thank you. Yeah, I don't think we received any. Yeah, we will answer the question afterwards. So the next speaker is from the Protect project, Anne Chapuis.
Well, hello everyone. Thank you so much for organizing this webinar. So I will present Protect Sea Level Projection tool. So like for CoCliCo, it's still in development. So I will not show you the tool in itself, but more to explain how we are designing it as both a scientific tool and a dissemination tool. So I would like to also thank Xenia, who has helped make this presentation, and other people from the project who have been working on that. So briefly, Guneri has introduced quite a lot the notion of sea level rise. So Protect is really working on sea level rise in the future due to the melting of land ice. And there is a work with the stakeholders in the co-design of what they need as data for future sea level projection. And also there is a part on the impact and future adaptation. So we have different work packages, as you can see on the right-hand side of this figure. So the work package 2, that is on the co-design and co-production of the sea level projection. The work package 7, that is working more on to make the global projection regional. And then the other work packages that are working more on the glacial processes for all glaciers on Earth. So there are around 200,000 glaciers on Earth, and the two big ice sheets, so the Greenland ice sheet and the Antarctic ice sheet, that if all those land ice contributors were to melt, it would raise sea level rise by 65 meters. But that's, of course, not for tomorrow, fortunately. So in Protect, we're working on both projection and different time scales. We have 27 partners and institutions located in 9 different countries in Europe. So why are we making a web tool with Protect? So Guneri in the presentation showed another existing web tool, that is the Climate Central tool. NASA also developed a sea level projection tool when the last IPCC report was released. So Protect was the NASA projection tool existed. So the idea was to make a tool to be able to present all the sea level projection data. So we are going to still do what we said we will do in the project, but we were thinking what could be the added value and what are still the limitation in the tool we are going to develop. So we'll still keep the limitation for the local scale, where we will not take the vertical land motion in consideration, like it is also not done in the NASA web tool. But we wanted to work more on how to make the tool useful and understandable by stakeholders. So we are including some sea level scenarios that meet real life needs. So I will explain to that a little later. We'll also give the possibility, thanks to special part of the web tool, to play with the different sea level components to better understand the contribution of each process. And also we try to disseminate to a wide audience thanks to the addition of educational content. So in this tool, then you will find the videos that we produced in Protect. There were some illustrations that were made for the web tool, and also some case studies. So it's still in development. So it look like first possibility. So it's based on an existing website that was hosted at the BRGM. And we are trying to just upgrade that website, including then like what I detailed before. The web tool, so we have, of course, the scientists of the project, the designers and programmers who are working to design and then make the web tool available. And we're also including a beta testing audience to make sure that we are creating something that's understandable and useful. So like the process has started some months ago, where scientists have been talking with designers to tell them their needs in terms of data, display, and what we would like to see on the web tool and where. Then at the time, the designers then discussed with the programmers, see what's possible to make. And then we started to test the first version we have. And then we get back to the scientists who then can adjust the data they are displaying, for example. But then, of course, it doesn't stop here, because then the designers can tell scientists what's possible, not possible to do. Same with the programmers, what are the limits, possible or not, etc. So it's quite a lot of back and forth between all those parties to try to make it as best as possible. We also asked the help from a scientific illustrator to make nice visuals, to make it more accessible. We also work with a video editor to make videos to be able to explain better the different parts of the web tool. And then, of course, all the different scientists of the project. So to make the web tool, we of course had to ask what was the objective with it and the audience. And then we had to answer quite some questions to make the science understandable. Which scenario would we display? Because it's, of course, as a stakeholders, could be complicated and hard to know which scenario to choose. So we're trying to guide them according to their need to orient them towards some scenarios. For the data, same thing. We produce quite some data. There is also already the projection from the IPCC available. So all that we had to think, which data are we going to put forward? Also the level of simplification, how much in detail do we go? Do we show like a more like simple version of the data, or do we put all the detail available? Also the color scale, what's best. We decided to stick to the IPCC color scale in that case. And also the timeline. The web tool before was accessible for projection every year until 2100, but we decided to stick only to every 10 years, for example. So it makes it a little simpler. So that's how the web tool looks like now. So we'll display the R6 projection, and then to be able to go further in time, we'll use the Protect Sea Level Rise projections. We have two modes to explore this web tool, so like a beginner mode where we just access the median result, so we cannot really go into the detail of the data, and an expert mode that allows to play more with the different component of sea level rise. And then we are making this dissemination effort that I was mentioning before. Then we are also explaining how to use those sea level rise projection within the real world decision problems. Because as Gunnar said, we want to make a tool that fits to the need of people. And so we want to show them how useful and how it can be used. So we have decided to take 3 case studies that are case studies that we are investigating in the project. So one is about the Maldives, one is in France, and one in the Netherlands. And for each, we have developed a storyline. So you see an example, for example, here on the right-hand side of the Netherlands. So there is a little text explaining the storyline, and then some illustration that give more detail, and it's also more attractive and easy to understand. So we have those 3 different contexts with 3 different needs of sea level scenario, different types of adaptations. And the web tool will be available, as you can see, both on like a tablet format, phone, or a computer. And we believe that the illustration will be really an added value. We also would like to make an effort in like the educational aspect by giving people more information about the background, what contributes to sea level rise. So we have built a glossary so we can convey to a wider public. So it will be a button you can click with all the sea level rise components defined. Like, for example, here there will be the mountain glaciers. So you see some illustration and link to the videos that we produced in the project. So all the different components that we produced will be gathered on this page. So we are using, whenever possible, the IPCC definitions, so we keep really something consistent. We have the Protect illustration and the video. Then I was talking before about this expert mode. So it's a default scenario where you can click or unclick the different components of sea level rise and see the effect it has on the map of sea level projection. So that this way you can test each component of the sea level rise up to 2150. Again, it enables us to illustrate, for example, here for Greenland, the destabilization of the Greenland ice sheet. So you have in a kind of cartoon-like small animation, again, linked to videos whenever needed, and the definition from the IPCC. So we are currently here working on to finish all the illustration, working with the designers so we can include or adjust the web tool, and it should be released by the end of the year. For your attention, and stay tuned for the release of the tool.
Perfect. Thank you very much, Anne. Yeah, I don't know if there is this question for you. Why is the vertical land motion not taken into account? Because we are a bit in advance with the
I
program.
can answer, and also if Goneri wants to jump in, don't hesitate. The reason why it's not vertical land motion is that it's very hard to. In Protect, we don't work on that aspect, like we don't project vertical land motion in the future. So I think that's why it's not going to be in the web tool. Goneri, correct me if I'm wrong.
You are perfectly right. I think the point is that vertical ground motion related to the glacial isostatic adjustment, so the response of the solid Earth to the past deglaciation is taken into account. However, the local vertical ground motion, which you can only assess using techniques like GNSS stations or INSAR, like interferometric radar from satellites, cannot be included today. There is still a need for research, and there is research ongoing on that topic.
Thank you. So the next speaker is from the West Coast project, Boris Barov.
Well, first of all, thank you for the invitation to take part in this interesting webinar. I will speak on behalf of several people, actually quite a lot of people from the West Coast project, who were generous and kind enough to let me use some of the slides and some of the work they have been working on in the last nearly 3 years. And I hope I'll do my best to present the progress there. My presentation will be slightly different than the previous speakers. I will not focus so much on the tools which the West Coast project is using, but rather on how these tools or how tools in general are used in real case restoration scenarios. We've already heard a lot about sea level rise, so I'm not going to say anything new here. I just want to say that there are two categories of factors that affect the impact of sea level rise on coastal ecosystems and on coastal communities. Some of those are natural forces like wave and tidal action compounded with the more difficult river discharge, and that creates risk of flooding. Others are related to the sediment transport from the rivers to the sea and the balance between coastal erosion and coastal accretion. And all this is exacerbated by the increasing frequency and intensity of extreme weather events, storms, and so on. So these are the natural forces. But there are also anthropogenic forces, like, for example, we know that the population increase in coastal areas has been tremendous. There is an increasing urbanization for various activities, including tourism, industry, and transport infrastructure, and so forth, and energy, of course. There is more and more of the coast is being built up with coastal defenses or with ports and barriers or various gray infrastructures. And the management of river basins, that's very important. Upstream has a tremendous impact on the coastal areas as well. So this is really a large-scale basin system that needs to take into account the whole river basin. And finally, there is a great issue with unsustainable management of water, mainly fresh water, abstraction for drinking, irrigation, industrial use, and in the same time deteriorating water quality. For example, in the sea itself, increased turbidity by dredging, by pollution, and so on. So all these natural and anthropogenic factors work together to generate stress on coastal ecosystems. So the West Coast project wants to address these impacts, which are rooted in climate change in coastal ecosystems. And for that reason, the project has prioritized the following issues it wants to address. The threats that it wants to address are related to erosion and the shoreline retreat, the increased flood risk, the disrupted sediment dynamics, including on a basin scale, the saltwater intrusion into the aquifers onshore and the impact that has on agriculture, for example, but also on water quality for other purposes, the loss of biodiversity, and finally also soil subsidence, which is one of the effects in coastal areas, which is caused by extraction, for example, of gas, or in areas with peatlands by peat oxidation, which leads to sinking of the coasts. So all these factors result in human suffering in general and economic damages, loss of marine resources, in further degradation of agricultural land, damaged infrastructure, various cultural and recreational challenges, such as loss of tourism and other impacts on well-being of coastal communities, which are well known. So the experimental aspect of the West Coast project relies on these 4 steps, but this is a project I want to say which is on one hand a research project, on the other hand very heavily an implementation project as well. So the main approach of the project is to use scientific tools to generate scenarios, to test those scenarios, to define goals, and test the different viable pathways for implementation of nature-based solutions and other strategies, including the financial and social aspects, the institutional and stakeholder arrangements, the long-term commitment of stakeholders in some way, and so on, and then to evaluate these pathways for their viability and for their success. And finally, to develop long-term adaptation plans, which will result in long-term contracts for coastal adaptation. As I mentioned, there is a large number of partners participating in the project. I have selected some of them to illustrate my talk with 5 cases, which illustrate 6 different approaches at 3 pilot sites. The pilot sites are 1 in France, the Rhone Delta, 2 in the Netherlands and Germany on the border, and 1 again in France, but a different area, the Arcachon Bay. And on the right-hand side, you can see the names of the colleagues from whose presentations I have taken a lot of the content for this talk. And the organizations that are leading the pilot restoration work in these cases are also illustrated with their logos. So thank you for all of them for the great work they have been doing. Now, let's start with the first case, the Rhone Delta. The approach there is a strategic retreat of the coastal defense wall. What is happening, I'll explain quickly. The baseline situation is that due to long-term exploitation of salt works, but in the context of current sea level rise, the profitability of salt works has been decreasing over time because the costs of maintenance of the sea defenses has been rising steeply. And there are also other challenges which are exogenous to the site, coming from water pollution from the River Rhone, and from local agricultural activities, effluents that influence the water quality of the site. So there is a complex set of issues which are being addressed in this case study. And the objectives are to restore natural coastal dynamics, to reconnect the lagoon to the sea, and by this to give the opportunity of natural dynamics to take care of many of those threats, and to enhance targeted habitats and ecosystem services, which biodiversity is providing in this Mediterranean wetlands. And all this is documented by detailed monitoring and evaluation studies in a view to develop upscaling strategies for the tools developed in this pilot site for similar coastal areas in the Mediterranean. Now, the restoration action itself, on the left-hand side, you see the map of the pilot area. The dashed black line illustrates where the coastal defense was concentrated in the past, and currently this coastal defense system is no longer maintained. And the dike, which is marked with red and purple here, is where coastal defenses are currently focusing. So you see that this generates around 4,600 hectares of lagoon, which is naturally connected to the sea. It also gives opportunity for the development or improved quality of different habitats, like the coastal lagoon itself, beaches and sand banks, Mediterranean halophytic scrub, as well as annual plants like Salicornia and other typical examples of hyperhaline flora, which is interesting and important for biodiversity. The restoration measures I mentioned already, the wall is not maintained anymore. And from that point onwards, there is a kind of spontaneous restoration of the ecosystem dynamic and of the exchange of marine seawater with the lagoon, which really addresses the increased pollution. It brings in fresh, so to speak, seawater into the system. And this combined with the efforts to improve water management in the catchment area, particularly with agriculture activities, and to create an integrated water management plan, results in an improved water quality in the whole wetland. Other benefits are the spontaneous and assisted restoration of habitats, which I mentioned earlier, which results in enhanced biodiversity and ecosystem services. And as I mentioned, monitoring activities are underway to document all these processes, and different tools are being used to model how these processes will develop in the future. For example, there is a digital model of the wave dynamic in the area. There is a digital model of water level rise and how this will affect the ecosystem, and so forth and so forth. On the graph on the right-hand side, you can see that we already registering improve of the habitat quality of different target habitats since 2021, particularly evident. So the achievements in this pilot case, there is certainly benefits in the restoration of coastal lagoons. New beach areas have been created, and you can see on the right-hand lower picture, one of the places where natural connectivity between the lagoon and the sea has been restored, which leads to the creation of these canals with dynamic exchange of water and sediments, which recreates these beaches on the protected side of these coastal former coastal defenses, which is it's a valuable pioneer habitat for biodiversity. Other ecosystem services which have been enhanced, the hydrosaline regulation has been improved, coastal flood risk reduction has been documented and achieved, and the coastal erosion risk has been as well reduced. There is an increased provisioning of fish stock from the system, and overall, in the long term, we expect there will be also significant impact on climate change regulation because of because of the microclimatic effects, but also because of carbon sequestration. Then one of the added values of these demonstration cases is great demonstration value and opportunity for application in the future, which demonstrates that large-scale strategic retreat is a tool which allows restoration, and it is a relatively low-cost strategy which can be adapted in specific cases. It creates a buffer zone which allows adaptation to climate change, and it has a high demonstrative value for ecosystem-based solutions, nature-based solutions. In the future, replication will be possible in similar Mediterranean lagoon contexts, but it is very important that to work with the stakeholders to explain the benefits of this approach, because people are asking questions when they see that the fences, for example, are being abandoned, or there is a processes being dynamic, and the public is not very well educated, and it's very important that this is addressed on time. So in terms of lessons learned. Quickly moving to the next cases. This one comes from the Waddenzee, which is, as probably you know, the largest intertidal wetlands in Europe, certainly, and probably one of the largest globally, if not the largest. It is extremely valuable for these salt marshes, intertidal mud areas, and mud flats, and various dynamic habitats on the coast. Extremely valuable for not only the fisheries, but for enormous amounts of migratory birds. And unfortunately, as many such coastal areas, it's also subject of significant pressures, mainly from shipping, but also from agriculture, from gas extraction. And I mentioned earlier, this results in various threats on the coast and in the sea and in the intertidal area. So one of the questions which is used as a basis for research and then experimental solution here is the how ecosystems adapt to and respond to extreme weather events. I'm sorry, there is some alarm which kicked off here. I don't know where it comes from. I need to stop it. Yeah, too many devices in this room. Sorry about that. Okay, excuse me. I stopped it successfully. So how coastal ecosystems respond to extreme weather events, and in this case, a particular storm was taken as an example. What are the possible coastal adaptation strategies in terms of the main coastal habitats which can provide such services? And in this case, the focus is on salt marshes and on seagrass restoration. In both studies show that the overall impact of this type of vegetation in coastal areas is attenuating the power of wave impacts, increasing the rate of sedimentation, and also counteracting coastal erosion. Through digital models and tools, this pilot case has really projected how this will look at the area and reduce wave energy and flood risk during extreme events. There has been an observed increased sediment deposition in marshy areas. The seagrass is also effective in damping the power of waves, including under sea level rise scenarios. This results in reduced sediment erosion and sediment mobilization, which is one of the factors which also results in a lower turbidity in the ecosystem, and improved water quality. Now, under sea level rise scenarios, however, in the larger context of the Wadden, not in the small particular pilot areas, due to the relatively small area covered by these two habitat types, the ability of salt marsh and seagrass to reduce wave damping is slightly lower, 5 to 10% lower, but still it shows capability to, in the long term, dampen waves, the power of waves and the erosion. So by restoring it on larger areas, this is still a viable strategy. Now, moving on in the same area, but on a slightly larger scale, which is the example of the Eems-Dollard Delta in the Netherlands, with under the province of Groningen, with a large number of partners. Here, associated with the high turbidity of the estuary, which is caused by wave action, but also by dredging and by deposition of silt from the dredging operations into the ecosystem. Another important threat is the soil subsidence, which is very pronounced because as a result of gas extraction and peat oxidation, and you can see on the picture here how this looks like in the field. So finding solutions for these type of problems requires a paradigm shift in the way Dutch coasts are managed, which opens space for restoring natural dynamics at large scale on the coasts, which is one of the valuable strategies tested in this pilot. So in the first step, of course, in such a large scale and long-term program is to define the vision, the short and the long-term vision and policy objectives for this large-scale restoration project, which has to take economy and ecology in balance. And this is how the overarching vision for the Eems-Dollard Delta is defined. That by 2050, the estuary will be a robust and resilient estuary with fitting dimensions and natural dynamics, healthy habitats, and smooth transitions between natural and urbanized areas and economic activities and ecology. The second step is to identify strategies which will take this vision into reality. And these 8 strategies have been identified in this case. The beneficial use of fine sediment for nature restoration, for agriculture, and for water management. Encouraging the sedimentation processes outside the dikes and using them for reinforcing natural areas, which means wetlands, flood, dynamic areas which are affected by floods, like the mud flats, for example. Restoration of new habitats inside the dikes, where the captured sediment can be used to, for example, be stored and sedimented and used in agricultural areas, by thus raising the level of the agricultural activities. The creation of refuges and, for example, nesting areas for birds during high tides in order to counteract the so-called coastal squeeze. Improving the waterbed and the underwater life quality. Also improved nature management inside and outside of the dikes, because the whole area is virtually covered in Natura 2000 sites. So it is extremely important to follow the requirements of the Birds and Habitats directives there. And finally, this is a cross-border system which requires the understanding, alignment, and policy coordination between different administrations and stakeholders at a large scale. So the next step is to identify specific projects about implementing those strategies. And I'm not going to go into any details, just want you to pay attention that some of those projects are completely focusing on the large scale strategic thinking. others are focusing on the ecology, while others are focusing on the economic activities. So there must be something for everyone in this context, so that stakeholder support is there and sustainability of the results is achieved. So just an example of the different measures or projects which are being implemented. For example, the sedimentation basins and kind of a technical measure to extract sediments from the sea and using the sediment for bank reinforcement, dike reinforcement, and for agricultural activities. Or measure 3, for example, the opening of the first dike and reinforcement of the second dike, and by thus creating intertidal area and area which is with a more dynamic management and ecosystem, and so on. I'm not going to go any further. The important element of this step is also to develop the strategic pathway in time, because these are long-term strategies, and in this case, the planning has been done until 2000. If you have one lesson from this case study, it is really to focus on this long-term vision and thinking and strategic evaluation of the different options. The strategic evaluation is done by the so-called quick scan tool, which is basically a multi-criteria analysis tool, which allows using data or modeling or expert judgment to evaluate the different alternatives and to select the most feasible option for development. And my final case study here, it's a quite interesting example of a technical measure which results in natural restoration of seagrass in the Arcachon Bay. Seagrass has been degraded in the context of the Arcachon Bay in the last years, in the last decades, mainly by heat waves and also the mechanical action of waves and wind, and also various contaminations which all together work in a compound way and create a system of negative feedback loops of degradation. So basically, seagrass is declining because it's mechanically being damaged, which on the other hand creates additional turbidity, additional deterioration of the conditions for photosynthesis, which again reduces the seagrass viability, and the various negative loops are just reinforcing each other. So the strategy selected here is to find a way to address and to turn this negative loop into a retroactively into a positive scenario. And what has been developed as a technical measure here is the so-called Roselier. It's a system which is aiming to reduce the initial mechanical impact of waves in order to create established. Been tried on small from deployment, scale deployment, and large scale restoration going on at the level of the whole basin of the Arcachon Bay. What happens at the side of this polygon area on the right hand side here is just a picture of one of those installations which is being deployed, which creates a sheltered area where seagrass can much more easily establish and develop. And with the picture showing the photosynthesis the photosynthesis in the area, you can see the establishment of seagrass around this structure. So in the long term, as I mentioned, until the end of the project, actually long term in the context of the project, this will be upscaled in the entire basin. and it will result in a significant increase of carbon sequestration in the seagrass, in stabilization of the seagrass itself as a habitat, which will result in improved water quality, reduced turbidity of the water, and various other beneficial effects on biodiversity and the ecosystem as a whole. And one big question mark is also to, which will be investigated in the future, is to evaluate and quantitatively evaluate the carbon sequestration potential of the system, both in the seagrass, but also in the mud, in the soil component. So, as conclusion for this particular case study, the installation of the Roselier has resulted in massive arrival of mud in the low energetic area, which increases sedimentation rates. Erosion of the degraded seagrass bed has been lowered. Healthy seagrass beds have started to accumulate and to restore and to accumulate further sediments. And the methodology shows that the accumulation rate measurement is essential because the carbon concentration alone does not happen only in the seagrass, but also there is a significant carbon stock also in the mud, which is in the bottom layer, basically, which is also fixed. However, the microorganism activity needs to be considered because for the moment we are not quite sure and it has not been measured so far. So, overall conclusions from my presentation. These pilot case studies under the Rest Coast project have demonstrated clearly the benefits of coastal restoration. There has been achieved enhanced balance of erosion and sedimentation, which reduces flooding risk. The restoration of natural barriers to sea level rise and storm surges has also been demonstrated. Healthy seagrass beds are particularly effective because they also impact and have positive effect on biodiversity, on carbon, on the mechanics of erosion and sedimentation, and so on, so multiple benefits. Improved water quality by reduced turbidity and natural filtration by vegetation is also very important and well demonstrated, which results in enhanced habitat for marine life, for biodiversity, fisheries, and for the ecosystem services in general. The ecosystems are themselves more resilient to climate change and other pressures. And of course, this results in community and socioeconomic benefits in many sectors, and finally in better quality of life for the growing coastal population. Now, I know that you probably have a lot of questions regarding specific cases, so I invite you to visit the Rest Coast website, where you can find many of these studies published as deliverables or scientific articles, but also to follow us on the social media, where you can learn more about the project. Thank you very much for the attention.
Thank you. Thank you very much. So now I give the floor to our last speaker, Ananya from Ireland, who will present us the Adapt4Coast Joint Policy Brief.
Yeah, hello everyone. So this policy brief will basically be a summary of kind of everything shared so far. And it's meant for policymakers, so it's concise and it's non-technical. So after this morning's information overload, hopefully this will be easier to follow for everyone. So this was developed and led by all of the different projects, but basically our team here at the Atlantic Technological University in Sligo coordinated everything. So as you can see, this is the policy brief. It's available on the website of our project, which is the EU SCORE project. So if you want to access it, I'll just quickly show you where you can. Just go to SCORE's website, and when you click on outputs, you go to other publications, and then that's the policy brief. So I invite you to read it for yourself, because like I said, it's concise and easy to read. So starting with the abstract, I wouldn't go too much into detail. And we have a brief introduction there, which basically highlights why we're doing what we're doing. So why all of these different projects are focusing on coastal cities across Europe, because they're really affected by climate change, especially sea level rise, increased flooding, erosion and other challenges. Like it's mentioned here, a lot of European cities face up to 2 meters of sea level rise by 2100, which is a lot. And these are some of the sort of main tools or main methodologies that we've been using as part of all the different projects. So the first one here is effective climate modeling and risk assessment. So like you saw in the different presentations, there's a lot of digital data modeling involved. The idea behind this is to improve our monitoring of climate risks, because if climate risks are not well understood, it's really difficult making effective policy, and it's challenging for policymakers, especially because a lot of these climate risks involve future projections, like 2 meters of sea level rise in the future. So how do we decide strategies that are long-term and effective in the long run, you know? So we have some strengths, weaknesses, proposed activities. This is, again, a very quick summary of different projects and different activities. The next one is ecosystem-based adaptation, which is sort of my area of specialty. So we've been working to do like a cost-benefit analysis, studying how EBA or ecosystem-based adaptation has different benefits for the community, like socioeconomic co-benefits. In SCORE, we've done, like I said, a cost-benefit analysis and a multi-criteria analysis with different stakeholders. And we're trying to also do a comparison with grey concrete infrastructure to see if EBA is actually indeed more effective or cost effective, and just better in the long run, easier to maintain in the long run. So here's again some weaknesses, proposed activities. The next one is citizen science and low-cost sensors. So my colleague earlier, also from ATU in Ireland, presented the low-cost sensor catalog, which I personally found it to be really accessible, easy to use. And we have that there so that basically researchers, policymakers around Europe and around the world can use some of those insights and ideas to like basically purchase low-cost sensors and engage their citizens in citizen science activities. Because the idea behind this is that when citizens get to monitor climate risks or climate change themselves, they feel a lot more involved in the project. So instead of just us scientists sort of generating knowledge and telling people what to do, when citizens are engaged more in gathering data, they're just more inspired to take climate action, and they understand better and just more awareness. They talk more about it, and that's really the idea behind citizen science. But then, of course, it can also, in some cases, help us improve the quality of our data, which, like I said, is really important. The next one is digital twin and GIS-based early warning system. So this is something we're working a lot in SCORE. And if some of you are not aware of it, digital twin is basically like a 3D modeling platform. So we've 10 case study areas in SCORE, and we've tried to model these 10 cities. They're 3D versions really, to see how different climate change impacts would affect these cities, but also how different interventions or strategies like EBAs would sort of reduce this impact. So it's real-time monitoring and visualization, which is why it's really cool. And it can also incorporate the needs of local stakeholders and citizens within the modeling. So it helps a lot. It can help a lot with decision-making for policymakers. The next one is the living lab model. So you might have heard some of us mention it earlier. A living lab is basically like a geographical region. It's a city or a region which we treat as a real life testing environment, where we engage with the local citizens to co-design solutions. So again, this is the whole idea of like knowledge co-production, instead of scientists going around being like, you know, this is the right way or this is what we should do. We involve citizens in co-creating knowledge, so they feel like they have ownership of knowledge. And a lot of times, because I work a lot with citizens, they really have a lot of really valuable insights, especially like if they're locals in a case study area, they would know a lot of details about maybe how sea level rise is affecting certain regions. So the Living Lab model is a really effective tool to bring together citizens with policymakers, with scientists, and with industry. That's the four sort of groups that we work with as part of the Living Lab. And again, in SCORE, we've set up these Living Labs in 10 different parts of Europe, which you can look into on the SCORE website. And then the last three, integrated coastal zone management, which is very, very important in Europe, it's a dynamic process to promote sustainable management of coastal zones, which uses informed participation and cooperation of stakeholders. And also, obviously, a lot of policy making is involved in this. So again, this is a very effective and sustainable way of planning, basically policy making, incorporating stakeholder needs, incorporating data, latest data. And this is one of the main sort of goals of all four projects, I would say, is to just manage coastal areas better. And then the seventh one is citizen engagement, which is, I think it's been sort of mentioned throughout the last hour and a half, because any successful adaptation project, research and studies show that they're really only successful with effective stakeholder engagement or citizen engagement, because citizens would help contextualize the decision problem and really incorporate local needs and local requirements, which again, we wouldn't be aware of. So this involves improving communication of climate-related information, designing a sustained engagement strategy, providing opportunities for inclusive dialogues, catalyzing stakeholders' mobilization, involvement, and action. So this is a very complicated process because it's very difficult, changing public behavior, motivating them to engage more with climate action. But this is probably the most important part of climate adaptation, because the groups that would be most affected by climate risks need to be engaged in climate policy making. I mean, that just makes sense. And the last one here is web-based platforms, including ICT and maritime spatial planning. So again, this was shared a bit earlier. The ICT platform being developed by SCORE collates and presents important climate data being gathered through the sensors that we mentioned and satellite imaging, a lot of satellite imaging, and as well as stakeholder data. So we engage with stakeholders, gather data from them. And the whole idea is to gather all of this data together, put it in an open access platform, and support decision makers, but also researchers. It inspires and motivates researchers and helps them with this platform, like a baseline platform, which they can develop their studies further on, basically. So this is a very quick summary. There's a lot going on in all of these projects, so I would encourage you again to look into the websites. We have some conclusions and recommendations to policymakers here. So we don't have too much time, so I won't go into them, but please have a look. And these are some of the contact details for the different projects and the websites as well. So like I shared earlier, you can always just go to the SCORE website and go to outputs, publications, and you would find this policy brief. So that's it from my side. Thank you everyone for your patience and your time. And I will hand it over now to Laura for questions and answers.
Yes, thank you very much, Ananya. It was very complete. I don't see any additional questions. Some of the questions were addressed during in the chat during the webinar. I don't know if any of you has additional questions. Otherwise, you have all the contacts you received here in the chat, the different links to the different project websites, and you can contact us by email. Don't hesitate. Maybe just to inform you that in addition to this policy brief that was presented, there is also another one that we on sea level rise that the SCORE, CoCliCo, and Protect projects drafted together at the end of 2022. and it was presented at the COP27 conference. So you may be interested to have a look. I put the link on the chat. And as the next steps for our Adapt4Coast cluster, we are planning to further collaborate in the next months with additional webinars and maybe some additional guidelines and documents and joint participation in events. If somebody of you is in Brussels, the SCORE project coordinator, Salem Garbia, will be there this week to attend there is the third forum of the mission on adaptation to climate change, which is taking place this week on Thursday, and where he will present the Adapt4Coast cluster with a joint poster presentation. And that's if you also you will receive a feedback questionnaire by email, which is very short but very useful for us to improve our next webinars. So you have the link here. Maeva just posted it. And I would like to thank all the presenters for their availability and their interesting presentations today. Thank you very much. And of course, thank you to all the attendees for joining us today.